So now let's build a little decentralized casino, which will have a function where people can send Ether to the contract, and then they have a 50-50% chance to win and double their money. And if they lose, then the contract will keep the money. So naturally, there needs to be some way to fund this contract, and people actually need to put enough Ether into the contract so other people can play. And of course, there would have to be a way for someone to actually retrieve the funds that this contract here will have. But we'll leave that out. We'll only focus on the actual game function. So to do that, we're going to use the randomness as we discussed before using a future block hash. So we'll need one mapping from address to uint256, which will keep track of the amount of Ether, or way to be precise, that people are playing. And then we'll need a second mapping also from address to uint256 for the block hashes to be used. So here we will keep track of the number of the block hash that is supposed to be used for each game. And then we have a function playGame, which is external and of course payable, so people can send Ether along. And then in the first case, when someone is calling this playGame for the first time, then we have to figure out that he's calling it the first time, and we'll check that by looking at block hashes to be used for msg.sender. And if that is 0, we know, okay, he called it the first time. And so we're not actually playing yet, we're only determining which block hash to be used for the randomness. So this is the first one now, and we'll store this for the msg.sender, and we'll use the block.number plus 2. So of course you could even use more, but 2 should be enough so that this block hash is not known at the time when the msg.sender is calling playGame the first time. And then we also store the amount that he played. So the Ether that he sent along in this call is msg.value, and we'll just keep the Ether in the contract, and then this will be determining the amount that he wins and if he wins. And so then we just return early. And otherwise we can play the actual game, because now in this case here we know, okay, this is now the second time that he's actually calling it. So now for the second time, let's require that he doesn't send any Ether, because he already did that the first time. So yes, he cannot play multiple games at the same time. And now we also have to check that the block is actually mined. So we'll check block hash of, and now just this number that we stored previously here. And that, of course, should not be 0. So now we know the block is mined, and we can safely calculate a random number. And we can just cast it directly into uint256 to get a number from this block hash here. And now we have a random uint256 number that we can use. So how do we determine if he wins? Well, that's really simple now. We just check if random number modulo 2 equals 0. Or in other words, if the random number turns out to be even, he wins. If it's odd, he loses. So in the case he loses, we don't have to do anything, we just keep the money. In the case he wins, well, now we have to send him some money back. So the amount he receives is, of course, the amount he previously sent here, and we stored it previously, times 2, because now he won. And now we just transfer it back in the way we did several times now. And that's msg.sender.call. And we send him the winning amount. Well, and if the transfer fails, too bad for him. And then at the end, we can just reset the state, so he could just play again. So we'll set the block hashes to be used to 0, and also his game value. And then for good measures, you could also check here that the random number is not 0. Although technically, we don't actually have to do that because we're already checking here if the block hash is not 0. But just keep that in mind that Ethereum can only look at the last 256 blocks. So if the player here should indeed fail to call this in time, it would always revert in this case here. Or if you have some other logic, then always check that the random number isn't 0 if you're using the block hash.